Hello, ladies and gentlemen. Welcome to Kinematics. We're now going to do question 7. Here's a cable car traveling to a vertical height as illustrated in 7.1. Now, the key concept for this question is that Szilard equations can't be used for the entire journey because the acceleration of the cable car is not constant. We need to break down the journey into segments where the acceleration is constant. So let's first figure out what are the 3 segments of the journey. So initially, the cable car starts from rest. So that means the initial speed here is 0. And then it accelerates at 1.5 meters per second for the first 2 seconds. Right, so that's acceleration is 1.5 meters per second. Then next, the cable car moves at constant speed for 120 seconds. And then after that, the cable car decelerates to rest in 3 seconds. So the acceleration here is negative. We don't know what the acceleration is. Calculate the vertical height moved by the cable car for the entire duration. So we have segment A, segment B, and segment C. Now, in order to make this question easier for us, we're going to define 2 new axes, alpha and beta, which are along the cable track. Right, so that way we don't have to worry about vertical and horizontal height for now. So first of all, let's talk about the displacement along the cable for segment A. Right, the displacement along the cable for segment A can be given by the equation S is equals to UT K plus half AT squared. So we use this equation because we know the acceleration as well as the time. And also we know the initial velocity. Initially, the cable car starts from rest. So we know 3 of the 5 variables. So we can find out what is the displacement in this case. So it's half 1.5 and t squared is 2 squared. So the initial distance traveled is 3 meters for the first part. Now what about for B? For B, we can also use the same formula. S is equals to UT, okay, plus half AT squared. However, for the segment B, the acceleration is 0 because the car moves at constant speed of 3 meters per second for 120 seconds. So what this means is that the displacement change for B will be 3 times 120, which this is 360 meters. What about the displacement for C? So we don't have the start and end. We don't have the acceleration, but we do have the start and the end velocities. The start velocity is 3 meters per second. The end velocity is 0, and the time of travel is 3 seconds over here in 3 seconds. Okay, so we don't need acceleration. We do need the speed. So we use the displacement. So we use the equation S equals to half U plus B T. So we can get half 3 and 3. So that is 4.5 meters. So the total distance traveled, okay, along the cable will be 3 plus 360 plus 4.5, and that is going to give us 367.5. Now what about vertical height traveled? Now so this is the distance along the cable is 367.5, and we want to have the vertical height traveled at an angle of 40 degrees. So because this is separated from the angle, so we use 367.5 sine 40 degrees. So the height traveled will be 367.5 sine 40. And that will give us 240 meters. So that's question 7. Okay, let's take a look at question 8. This is about parabolic motion. Now, before we begin question 8, let's write down the definition of parabolic motion. The parabolic motion is motion where there is constant velocity in one direction and constant acceleration in a perpendicular direction. Sorry, this should be a perpendicular direction. So, for example, in the case of parabolic motion near the Earth's surface, we have a ball that is moving with constant horizontal acceleration velocity in one direction, all right, which means to say that when the ball is traveling in parabolic motion, the horizontal component of the velocity will be constant all the time. And then we are also having constant vertical acceleration of 9.81 meters per second squared in a vertical direction also all the time, okay? 9.81 meters per second squared. So this fulfills the definition of parabolic motion. So please remember this definition. You might want to write it down. Parabolic motion is when there is constant velocity in one direction and constant acceleration in a perpendicular direction. So let's take a look at how to describe the variation of vertical velocity and vertical acceleration of the ball throughout the path. So initially, the vertical velocity is upwards. Now, so in describing velocity, there's three things you want to talk about: the direction, the change of the magnitude, and the rate of change of the magnitude. Basically, this is the direction, the velocity, and the acceleration. So initially the vertical velocity is upwards and it's slowing down. So we say the vertical velocity is decreasing in magnitude at a uniform rate. Uniform rate means constant acceleration. Now the vertical velocity is 0 at the top of the path, and on the way down, the vertical velocity is downwards, increasing in magnitude at a uniform rate. However, the acceleration is constant downwards with a magnitude of 9.81 meters per second squared. So this is how the vertical velocity and acceleration change. Describe the variation of the horizontal velocity and the horizontal acceleration of the ball throughout the path. Now, since there's no air resistance, the horizontal velocity will be towards the right with a constant magnitude, and the horizontal acceleration will be 0. Okay. Now, let's talk about the initial velocity, calculating the time of flight of the ball. Now, in order to do this, I would need to teach you a concept called suvatsu. Now, remember that for linear motion, we only use the concept suvat. Now there's parabolic motion. I'll introduce two new terms, TSU, su, which is the horizontal component of the motion. Now over here, this segment over here refers to the vertical motion, all right? And over here, this segment over here refers to the horizontal motion. Now, the t is a common variable between the two. So very commonly for suvatsu questions or parabolic motion questions, we want to find t. Okay, so let's take a look at the equations to be used in the vertical side of the house. This side will use the vertical equations. You need 3 of 5 data. Okay, for the horizontal equation, there's only one equation, s equals to uxt, because acceleration is 0. So there's no need to write acceleration value for any of the horizontal equations. So for this equation, you need 2 of the 3 data points, right? So on the left hand side, you need 3 data. On the right hand side, you need 2 data. So let's start the question, all right, with this method called suvatsu. The velocity of the ball is 14 meters per second at an angle of 30 degrees to the horizontal. Calculate the time of flight. So over here we have the starting point is 0, 0. We want to know what is the time for the ending point. So the ending point would be at the distance x, but the vertical displacement will be 0 and time t. So let's take a look at what data we can fill in. Over here, acceleration we can fill in first, 9 minus 9.81. The t is the one that we want to know. Okay, so what else do we have at first? The initial velocity of the ball is 14 meters per second at an angle of 30 degrees to the horizontal. So this is 30 degrees. So we can now do the vertical and horizontal velocities of the start. So this is u, this is uy, and this is ux. Okay, this is this is 30 degrees. and this is 14 meters per second. So doing that, we'll straight away be able to write 14 sine 30 as the vertical velocity and 14 cos 30 as the horizontal velocity. So now we can fill in two values, 14 sine 30 and over here 14 cos 30. Now we only need one more variable to fill in the left hand side equation. We need 3 data points. So let's take a look at the third data point over here. Now because this is a horizontal ground, its vertical displacement when it reaches the end will be 0. So this is 0. So now we have 3 data points. We don't need Vy. So we will use the equation S is equals to ut plus half at squared. Now this will be the vertical components, right, only since we are solving the left hand side. So now we can fill in the values over here. S is equals to u t plus half a. So half a is a very common value, so I'm going to put down minus 4.905 t squared. So to solve this equation, we get t equals to 0, right, or t equals to 1.43 seconds. So this is rejected because we want the value over here. T is 1.43. So now we need to calculate the horizontal distance traveled by the ball before hitting the ground. So once again, we can fill in the values, but this time we have 1.43. All right, so this point to this point, we're going to solve for x. The horizontal velocity, which we can copy down from before, is 14 cos 30. All right, so this is 14 cosine 30. So over here, we can use the horizontal equation, which is Sx is equals to uxt. So this will be Sx is equals to 14 cosine 30, and the time of flight to the end is 1.43 seconds. All right, so this will be 17.3 meters. Okay. Now the ball is now thrown at the same speed and angle from a cliff edge. The cliff height is 68 meters. Calculate the extra horizontal distance traveled by the ball before hitting the ground. So now we're going to fill in the value for the ball, okay, and it's traveling like this, okay, hit the ground. All right, so first of all, we need to fill in, we need to start point. The start point of the ball is always 0, 0. The end point of the ball is x and y. Now we know that the cliff is 68 meters tall, so the end point will be minus 68 because it's below the axis. Okay, so this is minus 68. Okay, so now let's take a look at the values that we have. Sy is minus 68. We need to find x. Okay, we also have the same initial speed 14 and the same initial angle 30. So this will be 14 sine 30. Acceleration is minus 9.81, and this will be 14 cosine 30. So all we need to do now is to find t again, and then we can solve for both sides. Okay. So once again, we shall use the equation that doesn't have v. Sy is equals to uyt plus half ayt squared. But this time, we'll put negative 68 for the displacement in the vertical direction. Okay, so this is 14 sine 30 t minus 4.905 and t squared. So we get two values. T is equals to minus 3.08, which we reject, or 4.50 seconds. So now we have t is 4.5 seconds. So we can find Sx. Sx is equals to uxt, which is 14 cosine 30 multiplied by 4.50, and that will give us 54.6 meters. Now, so they say we want to have the extra horizontal distance traveled, so we need to subtract away 17.3. So the original distance traveled was over here. This distance was 17.3. So what is the extra distance traveled? The extra distance traveled, meaning this distance over here, the extra distance traveled will be 54.6 minus 17.3, which is 37.3 meters. So this extra distance traveled over here will be 37.3 meters. And that is the end of this part. Let's go to do the next part, which is determine the impact velocity of the ball. So the impact velocity of the ball will be the sum of the horizontal and vertical velocities. We can just transfer our data over here, minus 9.81. This is 4.50. The distance that we travel is 54.6, and the speed over here is 14 cosine 30. So what we need to do is to find Vy. Okay, so let's take a look. The impact velocity of the ball just before it hits the ground, just before it hits the ground, is moving in this direction, V. So there is a horizontal component, a vertical component, and an angle theta. So we call this Vy, and this is Vx. Now we know that Vx will be unchanged because it is constant horizontal velocity. So the Vx will be 14 cos 30. But what is Vy? In order to find Vy, we can use any equation over here. Since we have 4 data points, let's use Vy is equals to Uy plus Ayt. Okay, so we get Vy is equals to 14 sine 30, which actually we have the value of Uy here, minus 9.81 multiplied by 4.5, which is the value of A and T over here. So what we'll get is that Vy is equals to negative 37.191 meters per second. Okay, so now that we have Vy, we can find the V. V will be equals to the square root of negative 37.191 squared plus bracket 14 cosine 30 squared. And this will be 39.1 meters per second. Now we need to know the direction theta. So theta will be equals to the arctan of Vy and Vx. So Vy over Vx. So this will be the arctan of 37.191, okay, divided by 14 cos 30. And this angle will be equals to 71.9 degrees. So what we can write is that V is equals to 39.1 meters per second, 72 degrees below the horizontal as shown. Right, so if we write below the horizontal as shown, we will be able, okay, to get full marks for the direction, even if you have written it slightly wrongly. Okay, so this is question 8. Okay, let's take a look at question 9. A ski jumper lands 96 meters from his takeoff point as shown in figure 9.1 below. The landing slope is an angle of 60 degrees and the jumper is in the air for 4.3 seconds. So now we need to find out the horizontal component of velocity and the vertical component of velocity. So let's fill in what we know. Okay, first of all, for every Suvatsu question, we start off, our starting point is given the coordinates 0, 0. So let's try to find the ending coordinates of this. Okay, now this distance here is 96 cos 60, and this distance here will be 96 sine 60 degrees. So let's start to fill in the values first. Okay, so we can say that Sx is equals to 96 cos 60 degrees, which if we work out the value will be equals to 48 meters. So we can fill in 48 meters here. Now Sy will be equals to minus 96 sine 60 degrees because it's going downwards. So if we write 96 sine 60, that will be negative 83.14 meters. So this will be negative 83.14 meters. So this will, the value over here, if we want to write the coordinates, it will be minus 48 sorry, it will be 48 minus 83.14. We can also fill in the acceleration is minus 9.81 and the time of flight is 4.3 seconds. So now we need to find uy and we don't have vy. So we will use the equation. Sorry, we need to find ux. Okay, and so we have these values over here. So we have sx is equals to uxt. So sx is 48, ux is unknown, and the t is 4.3, which gives us the ux value will be 11 meters per second. So we can fill in 11 meters per second over here. All right. Now we need to find the vertical component of the takeoff velocity. So what we're going to do is that we're going to fill in all the rest of the values again, 83.14. We need to know the vertical component, minus 9.81, is 4.3, the sx is 48, and the ux is 11. So now we need to find what is uy. Okay, so since we don't have vy, we will use the equation sy is equals to uyt minus plus half ayt squared. So let's fill in the value. Minus 83.14 is equals to uy 4.5 minus 4.905 and 4.5 squared. Sorry, not 4.5, it's 4.3. All right, 4.3 squared. All right, so solving for this, uy is equals to 1.8 meters per second. So uy, fill in 1.8 meters per second. Okay, so what is the initial velocity? So the initial velocity, if we take a look over here, uy is 1.8 and ux is 11. So we need to know what is the initial velocity u as well as the angle. So u will be equals to the square root of 1.8 squared plus 11 squared, which is 11.3 meters per second. Then what about the angle theta? The angle theta will be the arctan of 1.8 over 11. That's a very small angle. That's 9.0 degrees. Okay, so what we can say is that u is equals to 11.3 meters per second, 9.0 degrees above the horizontal as shown. All right, above horizontal as shown. Okay, now that is for question 9. Let's move on to question 10. Now in question 10, the concept for this first part is that there are two parts of the journey. This is part A. Part A is sliding down the slope. Now, remember that the Suvat equation can only be used for segments with constant acceleration, right? So we cannot use Suvat for this entire journey. Now, the part B journey will be hitting the ground. So this part B journey. So for part B journey will be parabolic motion. So we need to do two different parts of this question. Okay. Now, first of all, by considering forces, show that the acceleration of the tau when it's sliding down the slope is around 4.15 meters per second. Now, those of you who are in my class will know that how to write the forces on the slope, and you must be able to write it right immediately without thinking. So the first thing we'll write is the weight, mg sine theta. The next thing we'll write is the weight into the slope will be mg cosine theta. Next thing that we write will be the normal, which is mg cos theta. And the last thing that we'll write is friction. Now the friction force is equals to 0 because it said that this is a smooth roof. For smooth roof, the friction equals to 0. Alright, so there's no friction force. So over here, we can see that the resultant force on this object will be just mg sine theta. So we can write the F net is equals to mg sine theta downslope. Then we remember that acceleration will be equals to the force divided by mass will be equals to mg sine theta divided by the mass. So the acceleration will be g sine theta. So the acceleration downslope will be equals to 9.81 multiplied by sine 25. And this will give us a value of 4.15 meters per second. Hence or otherwise, calculate the speed of the tile just as it leaves the roof. So let us use the axis here as shown. This is the beta axis and this is the alpha axis. Alright, this is the tile and the acceleration is in this direction, 4.15 meters per second. So we can write over here, alright, what is the distance traveled for the tile? The distance traveled S is equals to 3.8 meters. So I put 3.8 meters here. The initial speed of the tile is 0. The acceleration of the tile is 4.15 meters per second. We want to find the value of v. And we don't have t, so we use the equation v squared is equals to u squared plus 2as. So we can write v squared is equals to 0 plus 2 times 3.8. Sorry, that's the distance traveled. So we'll put in the acceleration 4.15 multiplied by 3.8. And so v will be equals to 5.62 meters per second. Okay, so calculate the time taken for the tile to hit the ground after leaving the roof. Now this is how the tile travels in this direction. The initial speed will be 5.62 and then the angle underneath will be 25 degrees. So it's actually going down at the start. It's going to the left and going down. Okay, it's going to the left and down. Okay, so let's take a look at how we are going to set up this question. The height above the ground is 12.3 meters. So first of all, we'll start over here at 0, 0. Okay, and then we can take this distance here will be minus x and then minus y. So we know that the y is 12.3, so that will be minus 12.3. Okay, minus 12.3. So let me just write that again. Okay, so this is minus 12.3. So let's fill in the values that we know. Okay, taking downwards as positive, taking downwards as negative, we put negative 9.81. The distance traveled vertically is minus 12.3. The distance traveled horizontally is negative x. Okay, we don't know what is this distance. We don't know what is this time. Okay, now we have to look at the velocities carefully. So the velocity is as follows. Here is negative, here is 5.62 and this angle here is 25 degrees. So this will be the ux and this will be the uy. So straight away we can see that uy will be equals to negative 5.62 sine 25. The reason it's negative is because it's going downwards. So we write minus 5.62 sine 25 degrees. And the ux will be negative 5.62 cosine 25 degrees. So actually now we've got all the values that we need. Okay, so we can start to use the formula. So calculate the time taken for the tile to hit the ground. We can see that it's a left-hand side Suvat equation. We have 3 data points. So we can use Sy is equals to Uyt minus minus half at squared. So we'll put down negative 12.3 is equals to negative 5.62 sine 25 t minus 4.905 t squared. Now solving this equation in a calculator, right, gives us t is 1.35 seconds or negative 1.84, which is rejected. Right, so this is 1.35 seconds. So now we can fill in this value. Okay, t will be equals to negative 1.35. Sorry, 1.35. I'm getting confused with all the negative numbers. Okay, so now t is 1.35. And we want to find the horizontal distance from the edge of the roof at which the tile lands. So we want this one over here. So now we can use the equation Sx is equals to uxt. So this Sx will be 5.62 cosine 25 multiplied by t, which is 1.35 seconds. Okay, and this will be 6.88 meters. Sorry, this is negative 6.88 meters. So therefore, the distance is 6.88 meters. Okay, so it's negative because it's landing on the left side. You can take the leftwards positive if you want. Okay, I just tend to stick to one particular sign convention. Okay, and that is it for this topic. Congratulations and have a good holiday.